skolas vadītājiem.
Nē.
Tu taisi?
Jā.
Es skatos, kas spēlētam.
Spēlēts no Ķīnas.
Nu, jā. Tās tev ir vairumā.
Jā. Nu, sanāk 4 kapējiem par 5 gabalu. Nē, mazāk 3 kapējiem par 5 gabalu. Viņi maisina par 5.
Jā.
Un normāli. Ir vēl, tur kā skaitītājiem, tādas kā strāvas, tādas 10 gabali, 5 sarkani, pēc melnu. Nu, kā tam skaitītājiem. Lielas strāvas. Ir tādi pa normālu cenu un maziņi. Vai tādi tie paši strāvas ķēdes, tādi pati it kā ar zelta klājiem. Nu, šaubos, ka tas ir super zeltīgs zelts, bet izskatās diezgan. Izskatās estetiski, neko nevar teikt.
Jā. Estetiski.
A man ko?
Jā.
Es pamēģināšu, es no cita tirgotāja paņēmu eksperimenta mazi tīri metaliski. Pamēģināšu, kā izskatīsies. Tēks, kur tu esi? Mans dokuments. Dokuments.
Jā, matemātika. Es teikšu tā Krievijā matemātika tā ir rakstīt.
Nu, šo sēriju labāk nesagatavotam cilvēkam tur nav ko darīt. Tur tā rakstīts. Tā.
Pārsevāla vienādība.
Ja. Pārsevāla vienādība dot saite starp signāla spektrālo funkciju un signāla enerģiju. Nu, to kolektīvs kāds strādājas. Te viņi izsituši finansējumu.
Jā, nu to esi unikāls. Tu viņam vajadzēja kaut ko zināt akadēmijā.
Tūlīt es iešu zināt no akadēmijas.
Tev laiks uz zināt akadēmiju.
Kur vēl? Nē. Man kaut ko lūdzu vienkāršāk.
Tur vajag tik tā, ka sēdēt prezidiumos, ka teikt, jā. Tie īstie vidītāji tādi kā tu, neredzami. Tie, kas tur fotografējās, tikai izkārt.
Pārdzīvošais bez akadēmijiem. Retransform of periodic signal. Patrick. DFT mājas cilvēku. Nu, labi, nekas par dzīvi. Tā, ko es gribēju? somewhere. Can't take place. Nothing good there. Your previous education, power engineering or some kind of electronics?
Electrical and electronics engineering in bachelor's.
And bachelor, yeah, electrical engineering. And how you get without symmetrical components? It should be Fortescue transform or maybe Clark transform. Which one?
I don't know.
How can you know? How can you calculate something about a polyphase network, three-phase network, without symmetrical components?
Yes.
You don't have?
No.
What's the school? I need to write them. Because our education standard requires symmetrical components at first semester, second year.
Okay.
It's in basic course of electrotechnics theory. First timer. Second, computer application. It's also required by education, by professional standard. Not education, but professional standard.
Okay.
And next, master program, first semester master program,
Okay.
computer application in power engineering.
Oh.
This course mandatory requires symmetrical components. So I need to write to your school, shaming them for non-included vital part. And AC currents theory. You had?
AC machines.
Not machines, but circuits. What
AC
about circuits?
circuits.
Machines also good.
In my college, I have only AC machines and DC machines.
Okay, and what about circuits?
Electronic circuits.
Electronics. Your college need improvement. Not enough. Electronics is not enough. We need modeling of polyphase networks and transients in polyphase network. What about dynamics? Dynamics of polyphase network.
I don't know. I don't know the detail about that.
That's not good, because basic there is a problem. Basic dynamics is in bachelor program. Okay, I have some good news. What's the good news? On my YouTube channel, I left a recording from previous semester.
Okay.
So you can watch this computer application course just selecting lectures one by one, or no, they will attach you to the, if you, in theory you can ask your scientific advisor, Paul is your
Yes.
scientific advisor, to attach you to the course computer application, but it will be empty. Paul cannot, or I can do it. Wait a second, maybe I can do a trick. I'm not 100% sure. How can I spell it? Nanda Kumar.
Nanda
What is Nanda Kumar?
You call me Nandu.
Nandu? Ah. Yeah, for for Europeans. Sorry, I'm understand my surname also isn't easy for you.
Okay.
It's normal. It's because my grandfather was a kind of inventorist. So this surname is actually an award. It's award for 25 years of military service. My grandfather got surname as award for military service. Okay, you know what I'll try to do? I will try to attach you to the previous course as a listener. This will open you access to a learning system, a learning context. Oh. As I remember. Second. Oh, search showed free Nando here.
Free Nando?
Yeah, Nanda Kumar. I put your name, Nanda Kumar.
Yes.
And found 3 persons with this name. So possible, maybe your hidden brother. Okay.
How many students are registered in Smart Power System first year?
Totally some 20.
Okay.
No, not many. It
year?
isn't. It isn't. 1 second. Not your. Oh. Okay. System. Now you external student for the electrical network and computer-aided modeling. So you are now external student DAE 0636, and you will have access to course content, and it's a set of lectures, computer-aided modeling.
Okay.
I don't know. I think when you log on to Orto system, it will appear in your
yes. The 0633.
0636.
33.
36. 0636 should appear.
I can't see anything.
Yeah, so try to sign out and sign in again.
Okay.
Usually it's at moment you sign in into Moodle system, your set of course.
The same thing only I saw. I saw only 6 courses.
Spring, wait 1 second. It's your. Okay, you know what you can do? Open the fall semester.
Fall semester?
Yeah, 224 fall semester.
Okay, computer application in power engineering.
That's what I'm talking about.
Okay.
Now you have access because part of this will be required.
Okay.
And then we should start 10 minutes before. Where are?
So I am the only student or any other student? Any
other? Actually, I should see in your group. 1 second. I will. check users. 1, 2, 3. In your group, 3 students plus one more. There is one more group. One more group with Nino Johnson inside, with only one student. Here. This is no, why? Yeah. Victims. Okay. Anyway, I need to start. Falsy. What's this all about? What's this all about? Some words about what this course is and why it is needed and what we are all talking about. There are good things and bad things in this world.
Okay.
And bad things, our business is power engineering. We supply electricity to people. And our customers are happy and they pay us for energy supply. Yeah?
Yes.
But bad news, what power line and all equipment is subjected both to natural, negative things. Trees are falling, monkeys are running, all kinds of birds and animals try to kill themselves on power lines. Equipment ages, our personnel makes mistakes, and so on and so on. So bad things happen. We need to do something. What is our first line of defense? Disconnect damaged element, yeah? To keep running, system keeps running, okay, we have damaged line, disconnected. We may, yes, we may not supply energy to some customers, but we will not lose everything, okay? What else? So first line of defense is called relay protection. It's historical, relay protection. And relay protection works at first. Look, very simple. If something is damaged, disconnect it to continue operation. There is a second line of defense called system automation. We can do things on a level of the system, the whole supply system. I will start my course from beginning, so from simple protection. What's this?
It's a relay circuit.
Hey. Simple circuit breaker, yeah? What we got here? Coils, maybe where are you? What's here? Hey. When you understand things to disappear, that means what you getting for. Oh, here it is. This one is a bit better because it has nice visible coils. Current flows through coil. Force of current is opposed by force of this spring. If current is high enough, spring compresses and circuit disconnects.
Okay.
Nice, simple circuit breaker. How it operates? If current above threshold set, it's possible to program here. It has divisions. If current above threshold, this connect.
Okay.
Fine. Simple, easy, effective. This one, it's not so nice. What about this? 300 amps?
I don't know.
Yeah, it's same object. I don't have handle. And who is living here on the floor? This one is for 24 kilovolts. 200 kilovolts, 630 amps. But it don't have, small one have inner relays. This one needs external control. Okay, let's draw very basic circuit. Very simple circuit. A, B, C, and D are circuit breakers, like this one. true distribution network. And fault. It happens. I don't know, monkey jumped on a line. Strange. Lions never jump on monkeys. But monkeys do jump on the lines. We don't have monkeys here. We have timber guys. Most often, case of falls, forest, fallen tree, and human connected. Very often. Huh? Okay, fall. What should be done in case of fall? Line should be disconnected, yeah?
Yes.
And which one? I have A, B, C, D. Which circuit breaker should be disconnected?
It's a D.
Really? Will current disappear if I disconnect this?
No.
No. So D is wrong answer. Do we have better answer?
The fault occurs, there is no current in them.
And we need to, your job, send disconnect signal. Now it's connected. It's really should operate, but I will do it with my feet. I send the disconnect signal. Now current is interrupted. So, which circuit breaker should be disconnected?
I think B.
Yes. It's closest to the fault in the current flow path.
Yes.
If I disconnect C, nothing happens. If I disconnect A, what will? Will current disappear?
No.
Why? Do you see any more power sources here?
In
The only power sources.
Yes.
So if I disconnect A, I will clear the fault. But what's bad? Where's the problem? What will I lose? Customer. Profit. If I disconnect customer without necessity, I'll be fine. Not good. So here we are coming to idea. Its idea is protected zone. I need to have some device monitoring line and sending signal to disconnect. Relay protection.
Okay.
I also need it here. Relay protection. Take some information from my line, and if line is damaged, sends a disconnect signal. For this device, for its brain, for its logic, I can specify very important thing. It's protected zone. All faults here on this line
Yes.
should be cleared by switch B.
B.
All faults in line A, in first line,
C.
should be cleared by
A.
A. Yeah?
Yes.
So, this device with A should take a close watch on everything inside white balloon.
Okay.
Device 2, this one, B. All this should be,
Close watch.
and if damaged, line disconnected. Yes?
Yes.
For A, this is protected zone for A, white. Blue, protected zone for B.
B.
Yeah. And now I can put two definitions here. Definition number 1, internal fault. Internal fault is a fault inside protected zone. Inside designated or arranged protected zone. It's like, soldier, come here. Watch this, this, and this. Everything happen here, here, and here is internal.
Okay.
Something happens there, it's, if not internal, it's external. It is not your business, it's his business. You watch this, you watch this. Your problem here, your problem there. You do nothing if something happens there because it's not your business. So, internal fault is a fault inside of protected zone. External fault is a fault outside of protected zone. Clear? Clear. Now, two more definitions.
Okay.
Sensitivity
Sensitive.
and selectivity. Sensitivity is ability of protective device to sense internal faults. It's a criterion Yeah, we have them. Sensitivity is ability to sense internal faults.
Thermal force.
Internal faults.
Okay. Another one is
Can be characterized. I will use this designation. In Latvian, yod from juticles. It means sensitivity.
sensitivity.
It's a sensitivity factor. It's used to evaluate or rate protective device. It is current of minimal nozīmē internal. No Latvian iekšējs. It's internal fault.
Internal force.
current of minimal possible internal fault. Divided by E nostrāde. Kas ir nostrāde? It's a trip current.
What current?
Trip current. It's a threshold when relays disconnect.
Threshold current.
No, it's not a fault current. It is one moment. You have device. For example, device monitors current. This device monitors current, yeah?
Okay.
So, it is a threshold when it disconnects, yeah? It's a trip current.
Okay.
Fault current is what we will see during fault time. This trip current is what there should be a scale. There should be a tiny scale. How? It has it's programmable. For example, this one. No, not programmable. Only one. It has a current of 160 amps. Here it is. I can program
Okay.
this connection, this current with this dial. So, nostrāde or trip current is a current when disconnect signal is sent. So it's a set point. Fault current is a real current of network. So, sensitivity factor or jutīguma coefficients in Latvian is a ratio between minimal internal fault current and set point of my protection. When to trip. Good practice, it should be greater or equal with 1.2. So, sensitivity on Latvian jutīgums ir spēja atpazīt iekšējos bojumus. In English, ability to sense or identify internal faults. Second term is selectivity. What means selectivity? Selectivity is ability to discriminate external faults from internal. So, sensitivity characterizes how well my device works on internal faults. Selectivity, how well it's protected or safeguarded against false trip on external faults.
Okay.
Do not operate on external fault. Sensitivity is should be rated actually when you perform a project. You put it for approval. You need to prove what your device is sensitive. Otherwise, you will be sent back. No, your project is not approved. For selectivity, you need to perform analysis and key moment for non-selective operation. Possible compound will be fined and fined hard. It depends on local regulation. But non-selective operation means what KPI are not met. It's a serious, this kind, how to say, unjustified. I will not use that word. Unjustified disconnection of customers is a serious blow to your KPI. So, problem you need in your design of protection, you need to fulfill both criteria. You should ensure your device is sensitive and your device is selective. And that's not all. there are two more points. Safety of operation. Your design should be able to operate 24 hours, 7 days, many years. It should be reliable. Today no faults, tomorrow no faults, next day 10 faults. Your device should be reliable. This requires very, robust design and robust approach. Reliability isn't free. And your design should be economical, justified. If protected object, I don't know, to houses where nobody lives, most simplest design will be okay. If it, for example, chemical plant, where disaster can be real, true disasters, your funding will be open for you, and you will be able to use most advanced, top-grade device. So your design should be, adjusted to value of protected object. Fine. These are our basic ideas. More definition. I will use definition star. First, definition relay. What is relay? Have you heard about relay?
I don't know.
It's an actual French word. In some older time, France had a system of state hosts. If you entitled, you don't know, high rank commander or high rank civilian servant, you go with your horse, visit special, horse exchange center, and you can, of course, relax, but you can take next horse from the state-owned pool. Every 20, 30 kilometers they had such a special office or center where you can exchange your horse. From the state-owned, if you're entitled, you can use state horses. These centers will use railway. Can I? Railway. Big railway. Where's my big railway? My big railway in the big box. Big railway is. This thing is a current railway. It has coil. It's a good coil. And here, contact. If current is strong enough, contact system will close and send signal. So for ideal railway, if we take it as a box, for example, it can be any value, I don't know, current, voltage, pressure, something, input value. Output is a binary value. It can be only 0 or 1. Output for relays, output is binary, only closed or open. Input analog. I can draw a chart. 0, 0, 0, 1, 1, 1. Here is operation threshold. I can call. Actually, it's a, for this one, it's a trip current. Or in Latvian, trip is nostrāde. Trip when relay close circuit. Oh no, don't touch this one, it's damaged. Old, nice, 1954. It's a current relay. Coils, inside anchor and set of cones. Okay? Better example. Okay. I had okay. Bit modern design, it's a voltage relay. Coils, anchor, and contacts to give out
Open and
signal, open and close. And how the trip point is set? With the spring, I have a lever, I can select 40, 50, 60, 70, 80, or also factor 2 can be employed. For example, I'll set this and multiply 2, it will trip at 100 volts. For this relay, for example, voltage in ideal case 100 volts, output Y1. Relay function gives out 1 or 0, and if here I apply voltage, if voltage is below 100 volts, it gives out 0. If above, clicks, and I get logical 1. Very nice. Actually, I can, if I have time, I can show it in reality. Real relays do have difference between trip point and return point. What is return point? For example, my voltage, better like this. Let's say I increase my voltage. White line will be voltage and output will be in red. 0, 0, 0, 3.1. It's clear. In reality, it's an interesting thing. If I do like this, relay is 3. If I try in opposite direction, I will find an interesting thing. If I decrease voltage, I will find interesting thing. What my relay will return in some different point. In Latvian apgari aggression. It's a return voltage. Such kind of electromechanical relays, X, my input value, Y output. Going forward, I will have kind of this with X trip here. Going backward, X aggression. It's a return value. Yeah. In reality, real relays do have trip voltage or current or something, what they are. They can be pressure relays, or I don't know, power relays and so on. Higher than return. Return is when it came back. For simple interim relays, this one will have something like 0.8. Do I have some kind of simple so this one is too good. Where's my relay? Why everything disappears? This one is a good example. I can show it close. Marble founding. Nice. Copper and that. It's approximately 100 years old.
100 years old?
This? Well, approximately 100 years old. Marble base. And current, nice content. For this kind of relay, if you test it, you will find what triple ratio between trip and return. Approximately 0.3. For protection, such relay not good. For electromechanical relays, this ratio, return factor, in old days was limited by 0.83. Modern relays have this gap approximately 4%, meaning 0.96. I would like to draw attention to what? Trip Nostrad return aggression. I raise current, relays free. I decrease current, relays clears output circuit. Trip or Nostrad clears aggression. Yeah? And there is one more idea. I have some logic to inside there are some brain, some processing, some algorithm, something. There are 2 points in time. Point when all this logic, watching current, decided, oh, and current is it's too much. We need to clear fault, we need to disconnect line. And moment in time where actual signal to the circuit breaker is sent. You understand what? All this logic needs some time to do something. So there are two moments. Start or pick up moment. And trip moment itself, when signal is, output signal is sent. They are not ones. There is some time between. Oh, current is high enough. Let's do let's do disconnect, and actual signal is sent. There is a pickup moment. English name for it, pickup. Or start or palašana. In Latvian, it's palašana. Later, it's a start moment. Some use start, some use. Some scholars use terminology. Start is moment when supply power is applied to device. When device is, is energized. And pickup is a moment when current or our control, when line or protected object conditions are outside of normal, we need to operate. I will use mostly start time, but to explain, some scholars use terminology. Start moment is moment when power is applied to a relay itself. And then you plug on your phone, it's a start moment.
Yes.
Your phone see your face and start face recognition, it's a pickup. And it's decided that you can go in, it's a trip. Yes. So here are my tiny basics. Basics. Where to go forward? Okay, where to go forward? Just to, put a milestones or direction indicators. What kind of protection will we start? First group, simple protections which operate on basis of idea current is. Okay, it's a trip current. Overcurrent protections. OCP is an overcurrent protection. Sometimes I will, it's unavoidable. I can also write MSI. Maximal Stravas aizsardzība. It's in Latvian maximal. It's a maximum. S from Strava current. A aizsardzība, it's a protection. If I write MSA, it's an overcurrent protection.
Okay.
Just, it can happen, I can write Latvian designation automatically. So all overcurrent protection operate, do disconnect line or, I don't know, it can be transformer protection or something if current is above threshold.
Good threshold.
Yeah. You said threshold, you need to perform fault modeling. This allows you to say, okay, now I see for this one 100 up is normal, 120. it's suspicious, but 200 is definitely a fault. So if current is above 200, I disconnect. I send disconnection signal. Okay, 200, 2000 maybe. Anyway, if current is above, I do disconnect. Over current protection. OLP or PSA. OLP is a subset of overcurrent protection, a overload protection.
Overload protection.
Yeah. PSA, PS parcelates in Latvian overload. OLP overload protection.
No.
Zero sequence current. You need to know what is a zero sequence. So, zero sequence current. EFP, Earth fault protection. In Latvian ZSE, Zemes slēguma aizsardzība. Zeme is Earth, slēgums. Izslēgums, fault, are aizsardzība protection. So, EFP, it's an Earth fault protection.
What's the meaning of P?
Earth, E-A-R-T-H. Earth fault protection. Earth fault protection operates on zero sequence current.
Okay.
Earth fault protection. Over voltage protection, under voltage protection. Over voltage and under voltage. Whoa. Oops. Collision. Non-correct definition, protection with so-called minimal impedance protection. This is not a well definition. Well definition is complex impedance belongs to trip area. Correct definition is complex impedance. Oh yeah, electrotechnics. What about AC circuits? What's your knowledge in AC circuits?
I have a little bit learned.
I rely heavily. So such kind of protection are named distance protection. Distance protection or distance isolation. DP, distance protection. Distance protection. It's because observed resistance of fault circuit is proportional to distance in lines is proportional to distance from substation to the fault place. Distance protection. Protection it operates measuring, for example, your line resistance. And it trips if resistance is below threshold. Actually, it requires definition of the trip area. Good, no good, it's in areas. Distance protection. Protection devices which use current difference or current Kirchhoff law. KCL, Kirchhoff current law. Do we have? Do you know KCL?
Yes, yes.
Sum of currents in any node equals to 0. So protection which checks Kirchhoff current law will be correct, operates on current difference, will be differential protection. Or also it has an often named as pilot wire. Differential protection sometimes hides as a pilot wire protection. It's because you need a special way to get signal from the remote end of the line. So pilot wire or differential protection operates on base of Kirchhoff current law. If energy disappears, highly possible, highly likely it's a fault. Online viewers, do you hear everything normal? No problems. I think I have time, so I can show one thing. This one.
What's this?
It's a current balance.
Current balance.
Yeah, it's a current balance. 1 second, I will. Okay, 1 minute. I will try to assemble small network. This is my current balance. The one and only. You can find the base which pi produce them in quantity, but arms are made in only one these two will be my load. This one and this one. I want to simulate. Let's see. Socks. One and two customers. What the ball? Wall current. I definitely need to measure. Meter will measure current in the circuit. This is my circuit breaker. everything here except except two elements. How will I get trip signal without trip circuit? Feeling battery is depleted. watching online. I'll bring current balance closer. Here it is, current balance. So, what's in there? What do we see? I have a coil on the right side, yeah? And balance of two steel balls. If it tilts like this, can you hear?
Yes.
It's a trip signal. It's been sent by this company,
Okay.
group. Here is network current, and this pair is my load. Also, I have a magnet on a movable arm here. If current flows in coil, what it pulls the ball down. Magnet pulls the ball up, like this. I will, yeah. Now, let's see. Load is activated. Current flows. Everything fine. Customers pay. More load. Everything fine. Customer pay. I would like to show one moment. Second, I will disappear. I need to make anyway current balance. Oh, this plot. I'm activating circuit breaker. Oh, it happened. You saw it? What's this? What happened?
Current will increase.
Yeah, current increase. It's a load inrush current.
What current?
Inrush. Startup current.
Startup current.
Yeah. For real loads, it's nothing special to see things like this. It's in rush or start up current. I deliberate make a wrong this setup of protection is wrong. It strips on load in rush current to start up. In case like this, see, I can switch.
Okay.
It's fine. It's working.
What's the name of the device?
Which one?
I,
The switch?
yes.
It's simple, it's switch.
Okay.
Two.
A switch only.
Two switch,
Okay.
block, one input, two output.
Okay.
One word. Second word. Both words. Again, this. I started with the wrong setup. What do I need? Increase trip
Trip signal.
current.
Trip.
Move up, off. I have increased the current. What now? No false
Okay.
operation. Very nice. Come here. What?
Okay. It will increase.
What happened?
It will increase only in meter.
I make a short circuit.
Yes.
It's a fault. Oh,
Trip signal.
this is correct operation of protection, yes? And if I increase footer, increase trip current, oh,
Okay.
nothing happens. That means what? No sensitivity. Fault, fault. But I selected. Still not. This one okay. First, what conclusions from this? Start, oh,
Started. Correct.
between start and trip is a gap, yeah? Switch now. What happens?
Started.
Start, but without trip. Starts and returns. Starts and returns. If current clear, fault current cleared before trip, protection device returns.
Electric file.
It's up, full return. Operates,
Okay.
starts, up, returns without trip. Fault cleared. Start, trip. Up, start,
And trip.
and trip. Signal clear. Fault was sent. Once more to camera disconnected. Start and return. Fault cleared before trip. Start and trip. Relay send a signal. Start without trip. Start, trip, fault current clear. And one more. This problem. False trip on inrush current. So, conclude? We need to select operation parameters to, on the one side, we are not allowed to operate on load current. This means what bottom line is a maximum load current. Yeah? And what is the top line? Minimal internal fault. We need to clear it. Advertisement of cakes. Okay. And what changes magnets? What changed my magnet position? Set point. In my case, trip current or setting. If I have only one adjustable parameter, it will be set point. Group settings. Oh. Key moment, I need to be able to identify correct settings to make my protection operate well. What means well? Trip when it's needed, so being sensitive, and do not trip when it's not needed, being selective. Here we saw small protection device. Operates.
It's a normal meter or voltage or current?
It's current.
Current meter.
Current related. It's a simple overcurrent protection. It's reacts to current. Simple overcurrent protection. One and only. Okay. My online people, do you have any questions? Oh, nice current device. Lot of copper in. It's for. It's marking. Double nominal current, and it's nominal 400, so it's for 800 ohms. It strips at 800 ohms. No more questions. Okay.